Welcome, class. This is an introduction to your calculus project, your last one. And we're going to be using calculus to learn how to approximate. And so there are a couple of goals here, so I want to make sure to introduce kind of what's going on here. Basically, we're going to figure out different techniques to approximate integrals. And these are the things that we've kind of been skipping. A lot of them are in section 6, but some of them are in section 8, or in chapter 8 and chapter 6. To make these a little bit more interesting, I do want to teach you how to use Desmos, and so I am going to use the computer and the screen a lot, capture the screen so you can see how we can use Desmos to implement these techniques. And the important part, especially for those of you that are going to use calculus later on in your careers, there are some error formulas that are associated with each technique, and it's good to understand what they are, how they help us. Specifically, it helps us save memory for computers, and that's sort of the discussion we're going to have. And of course, you'll have many opportunities to kind of share some feedback, as long as you do this in a timely manner. Okay, so here's the big question. So here's an integral that I have. It's the integral of e to the x squared dx from 0 to 1. And I want to use this integral to kind of explore the different techniques for approximating. This integral is actually impossible to do with the techniques that you learned in chapter 6. So in chapter 6, you learned integration by parts, you learned partial fraction decomposition. We also learned integration techniques that use trigonometry, and unfortunately, none of these will help us. None of these will work. There is no way to do this with those techniques. And so mathematicians have been struggling, or were struggling for a few years to kind of figure out how to approximate these types of integrals. And so we're going to use Desmos to kind of explore this function in case, or this integral, in case you're not sure what it looks like. So let me get out of this one and go to here we go, and go to this one. So the function that we're basically looking at here is e to the x and then squared. So it looks like this. And I only want it from 0 to 1. So for those of you that are new to Desmos, hey, you can follow along when you get a chance. You can always pause this video, but I'm going to put the braces, I call them the squiggly brackets, and write 0 is less than or equal to. You'll find the less than or equal to here, down here in the screen. X less than or equal to 1. And this is the function we're interested in right in here. We're basically interested in finding the area underneath this. And there's actually a lot of programs on Desmos that allow you, and the idea behind this is I kind of want to show you how to create some of them. Now we won't be able to do all of them, I'll let you explore, but there is this program I found online that somebody else had created, and notice here's my function, e to the x squared from 0 to 1. And what you learned, I want to kind of really quickly go over a few of the techniques that you should have learned in Calc 1. So in Calc 1, you were taught about Riemann sums. Let's make some smaller rectangles. And you were taught that you can approximate an integral by making these rectangles. Notice that if you look down here, it's about a quarter and a half, and so on. So you can make these 4 rectangles. And the way you would do this is you'd find the area, the length of the base, or the width, I guess, times the height. And then the length of the base times the height. And so this is sort of what this will do. And here is their calculations, the approximation is 1.27. And let me make this slightly bigger so we can see. Their approximation is 1.27, but the actual integral approximately is 1.46. And then also in Calc 1, you should have learned about the right-hand limit. And so I'm going to put in a 1 over here. So here is the right-hand Riemann sum. Okay, it's also an approximation, and notice now it's 1.7, so now it's actually bigger. And then here's the area associated with this, and so this is kind of something that you learn in Calc 1. Something that we skipped in our calculus class, but I want to come over right now, is the midpoint formula. So instead of using the right, so notice that these rectangles use the right-hand point, right here, the point on the right, to determine the height. And earlier, I actually had used the points on the left. I had used the points on the left to determine the left-hand point, to determine the heights of the rectangles. There is another method that we sort of skipped, and the method is that you can use the midpoint. So instead of using the left or the right, notice that this is the point in the middle. And so we want to learn how to sort of program this and how to compute this ourselves instead of having somebody else do it for us. Now, of course, if you ever need it, now you know that you can search for it, so this is really good. Okay, so what is it that we're doing here? Okay, so we want to do this for ourselves, here's a function that we're interested in. And so we want to approximate and we want to make these rectangles. So I'm going to, I'm going to go ahead and